Oh, Math 6 students, 10.3 extension. Choosing appropriate measures. So you've already done 10.3. This is an extension, and it's a really important one because it tells us which measures of center and variation we should use given certain data sets. So the essential question: how do outliers, what are outliers? Remember those data values that are way different than the rest of the data? How do outliers and the shape of a distribution, remember we talked about shapes of distributions in 10.3, symmetric, skewed left and skewed right, affect which measures of center and variation to use? So outliers and the shape of a distribution can inform us of which measures of center and variation to use. Okay, we'll get back to this. I'm going to go to just a review of what measures of center are and what the measures of variation are. Let's do a quick review of what these are. Measures of center and measures of variation. What are the measures of center? Hopefully you remember, they're the 3 M's. It kind of makes me want M&Ms. Now I'm hungry. Thanks a lot, everybody. Okay, what are they? They're mean, which is like the average, right? You find the sum of all the data, you divide by how many data there are. The median, which is the middle if the data is least to greatest. Remember, you order your data least to greatest since the middle value is least to greatest. And the mode, which is the value that comes up the most often, right? Those are the 3 M's: mean, median, and mode. What are measures of variation? Well, measures of variation are trying to tell you how spread out the data are. Measures of center are trying to tell you what's one number that describes the data set. Measures of variation include things like the range. How spread out are the data? You take the greatest value, you subtract the least value, right? That tells you kind of how spread out the data are. But sometimes you have outliers and the range is huge. So in that case, you use the interquartile range. And the interquartile range we call the IQR. You take quartile 3, you subtract quartile 1. Remember the quartiles? You order the data least to greatest. You have that cut in the middle, which is the median, and then you make the 2 cuts on the middle of each side, each half of the data. And that way you cut out the outliers when you're finding the range of just that middle 50% of the data. And then you have the mean absolute deviation. Remember the 3 steps? And it's the average distance of data from the mean. Remember, you find the mean, you make a list of deviations, and then you find the average of that list, or the mean of that list. Okay, so measures of center, the 3 M's, mean, median, and mode. Measures of variation, range, interquartile range, which is IQR, and mean absolute deviation, which is the MAD. Okay, different data sets will tell you which one of these, mean, median, or mode, is the best one to use. It will also tell us which one of the measures of variation you use, the range, interquartile range, or mean absolute deviation. Let's take a look. Data set 1, the amount of money in the bank accounts of creatures in Bikini Bottom. Okay, let's see. We have Patrick has $1 in his bank account. SpongeBob, who's a good saver, has $500. Squidward has $100. Sandy has $1,000. It's all that science and math she knows. Plankton has $5, and Miss Puff has $700. Okay? Now, how are these data distributed? Let's think about this. What numbers, what number would describe this data set? Well, are there any outliers? Maybe 1's an outlier. Maybe 1,000's an outlier, but it's hard to say if they're big outliers. Let's say if I take the range, if I found the range, so the measure of variation with the range, I take the greatest value, which is 1,000. I subtract the least value, which is poor Sponge or Patrick. I subtract $1. 1,000 minus 1, that's 999. So the range says that these data are spread among $999. That kind of makes sense, right? Well, what if there was another visitor to Bikini Bottom? What if everything was the same? You have Patrick, you have SpongeBob, you have Squidward, you have Sandy, you have Plankton, you have Miss Puff, and say you also have Bill Gates. Now, Bill Gates has about 104, let's see, 3 commas. Every comma, first comma is 1,000, second comma is 1,000,000, third comma is 1 billion. So he has about $104 billion. Now let's think of which measure of variation would work. In our last data set, we tried the range. The range is taking the greatest value, 1,000, subtracting the least value, which is 1. That's about $999. Now, if we found the range, you'd have to take 104 billion and subtract 1, which means that these data are spread among 103,999,999,999. Does that describe this data set very well? Doesn't that say like the data are spread over this huge amount? But think, Bill Gates that's an outlier. So that measure of variation that we're using, range, the range is affected by outliers. And so we probably shouldn't use range if there's an outlier. What would be better is to use the interquartile range. Remember, when we find the interquartile range, we're only finding the range between quartile 3 and quartile 1. We're cutting out the outliers. We can look at that more closely when we actually do examples. But hopefully you're getting where this is going. How about measures of center? Which one of these, mean, median, or mode, did we say was really affected by outliers? Hopefully you remember the mean. The average is really affected by outliers. So when you're looking at this data set where there aren't really any outliers, could we use the mean to find the measure center? Yeah, sure, that sounds good. The mean's a good number to describe what the average is of that data set, a good one number description. Would the mean be good in this case? No, because this outlier would make the mean huge. It would make it seem like everyone in Bikini Bottom was a billionaire, and that's just not true. Most of the creatures in Bikini Bottom aren't billionaires, so it wouldn't make sense to describe them as billionaires. So now going back to the key idea here, choosing the appropriate measures of center and variation. The mean absolute deviation, MAD, uses the mean in its calculation. So when when a data distribution is symmetric, use the mean to describe the center and use the MAD to describe the variation. Okay, what does this mean? Remember we talked about symmetric data? Remember symmetric data, most of the data is in the middle. It's that symmetrical distribution. And so if most of the data are in the middle, you can just use the mean because it's going to be right there and about in the middle. And the mean's going to describe the center. And then you can use the mean, which one of our measures of variation uses the mean? Which one? Which measure of variation uses the mean? Oh yeah, the mean absolute deviation. It's in the name. So if you have a symmetric data set, the best measure of center is the mean. The best measure of variation is the mean absolute deviation. Okay. The interquartile range uses quartiles in its calculation. So when the data distribution is skewed left or right, use the median to describe the center. I should have highlighted describe. And then which one of our measures of variation uses the median? Do you guys remember that we talked about how IQR, the interquartile range, you have to order the data from least to greatest to make the cut in the middle? And so the IQR is the best measure of variation to use if the data are skewed. Why is that? If the data are skewed, that means most of the data are to the left or to the right in our distribution. And so that's going to affect, basically you're creating little outliers where on the tail, I don't know if you guys remember this, but like skewed data was like the slide and you had, this is like skewed left. These can be thought of as outliers that are pulling the mean to the left. They're pulling the mean to the left. And so the mean is affected by them. So we use the median, which is going to be more representative of where most of the data are. The median will be a better measure. Okay, that's the end of part 1 of this video. And then we're going to go on to part 2. So I'll see you in a second.